Hi students, in this lesson we're going to look at how to solve simultaneous equations, this time using elimination. Alright, so the learning goals for this video. So after watching this video, you should be able to solve simultaneous equations using a process called elimination. Now some things you'll need to know as we think about solving equations by elimination. First of all, we're going to be using a lot of lines in standard form, so remembering that this is the way that we express lines in standard form. A good thing to remember as well is that coefficients are the numbers in front of variables. So for example, if we've got an equation like this, 4x squared minus 3x, the coefficient of the x squared term is 4. The coefficient of the x term is negative 3. So that coefficient is the number in front of our variables, and then we also need to remember how to use lowest common multiples. Alright, so for solving using simultaneous equations using elimination, what we're doing is adding or subtracting one equation from another, eliminating one variable, making it simpler to solve. Now this is best used when both equations are in standard form. As we've seen on the previous slide, we should remember what standard form is. Now here are our steps for solving simultaneous equations using elimination. A lot of the steps you'll notice are similar. It's largely step 2 and step 3 that are different. So we still number our equations like we do when we're solving using substitution. Now this step is new. Multiply one or both equations by a value that makes the coefficient of one variable, so the number in front of one variable, the same in both equations, or one as the negative of the other. So for example, both variables could be negative 2, or one value could be negative 2 and one value could be positive 2. We'll do one example of each coming up. We then add or subtract our equations to eliminate the variables, and from there our steps are the same as using substitution. Solve for one variable, substitute that variable into one of the other equations to solve for the second variable, and then check our solution. Alright, so let's try using elimination on one of on these equations here. 3x minus y equals 10 and 4x plus 2y equals 20. Now, in this situation, we want to make the coefficients of either the x terms the same, or one the negative of the other, or the coefficient of the y terms the same, one being the coefficient or one being the negative of the other. Now, the easiest way to do that may actually be to take our first equation, equation 1, and times it by 2. If we times everything by 2, then that y term will have a coefficient of negative 2, which is good. That's what we were after. So equation 1 multiplied by 2, 6x minus 2y equals 20. We'll call that equation 3. And now, notice that for equation 2, the coefficient of the y term is 2. In equation 3, the coefficient of the y term is negative 2. And that's great. That's exactly what we're after. They could also both be the same, both be positive 2, but one positive, one negative is fine too. Now what I'm going to do is write equation 2 directly underneath. Now what we're going to do is add these equations together. So 6x plus 6x plus 4x is 10x. Then this is where the elimination happens. Negative 2y plus 2y, those cancel out, and we're not left with any y's at all. We have effectively eliminated that variable. And then we've got 20 plus 20 equals 40. And from there we can start rearranging. Dividing by 10, our x value must be 4. And then we can start using our substitution to find out our value for y. So we'll substitute x equals 4 into equation 1. So substitute 4 in for that into equation 1, we'll have 12 minus y equals 10. Just by inspection we can say y must equal 2. We could just rearrange that, but we also know 12 minus 2 equals 10. From there we can do a check using equation 2. So bearing in mind, if we used equation 1 to solve for our second variable, we need to use equation 2 to do our check. So doing our check, the left-hand side of our equation is going to be 4 times 3 plus 2 times 2 4 times 3 is 12. Sorry, that should be 4 times 4, not 4 times 3. 4 times 4 is 16, plus 2 times 2, which is 4, gives us 20, which equals our right-hand side. So therefore, the solution is x equals 4, y equals 2, or remember we can just write that as a set of coordinates for 2. That's where those two lines cross. Alright, that's our first example using elimination. That one was pretty straightforward. We only had to multiply one equation by some value to get those coefficients the same. Now in our second example, we're going to look at what happens if we need to multiply both equations. So here, at 5 and 3, we can't eliminate that very easily. For the second term, the y terms 2 and 5, we can't eliminate those very easily either. So what we're going to have to do in this situation is multiply both equations by some number. So in this case, we want to try and make the coefficients of, let's just say, this time, let's just go with our x terms and make them the same. Basically, what we're looking for is a multiple of 3 and 5 that we can change them both to. We may as well make it 15. Right? So if we change the coefficient of the first equation of x in the first equation to 15, and the coefficient of x in the second equation to 15, we'll be able to eliminate those. So equation 1, we're going to multiply by 3. That'll be 15x plus 6y equals 60. And then equation 2, we're going to multiply by 5. So that'll be 15x plus 25y equals 90. Now from there, we can now do our elimination. So because our x's are the same, right, our x coefficients are the same, we can do elimination. Adding them will not eliminate the terms. That'll be 15 plus 15. This time we're going to subtract our terms. So let's call that equation 3, that equation 4. This time we're going to subtract these equations. So 15 subtract 15, that gives us 0. Those cancel out. 6 subtract 25 will give us negative 19y. And then 60 minus 90 will give us negative 30. Rearranging, y is going to be positive 30 over 19 because the negatives will cancel each other out. Let's substitute that into our first equation. Subbing into our first equation, 5x will equal, plus 2 times 30 over 19, so that'll be 2 times 30, which is 60, over 19 equals 20. Rearranging, 5x will equal 20, written as over 19. That'll be 380 over 19. So I doubled 19, times it by 2 to get 38, and then times by 10, put a 0 on the end. So 19 times 2 is 38, then put a 0 on the end. Subtract 60 over 19, which equals 320 over 19. And then dividing by 5, x equals 5 into 32 goes 6, regroup the 2, 5 into 20 goes 4 over 19. I'm not going to check that, that'll take too long. So therefore our solution is, our x value is 64 on 19, our y value is 30 on 19. And that's how we solve simultaneous equations, by multiplying both equations by some value to make the coefficients the same. Alright, so after watching this video, students, you should be able to solve simultaneous equations using elimination.